Alright, our next video is on dividing exponential expressions. So far we've learned how to multiply them and also how to do powers of powers, and now we're going to look at dividing. So we can start off by looking at examples and writing them out in longhand. So for example, maybe you have x to the fifth over x to the third. And if you write it out, x to the fifth means you have x times x times x times x times x. So you have the x multiplied by itself 5 times. That's what the exponent tells you. And then in the denominator you have x to the third power, which means x times x times x 3 times. And you can see by regular rules of division that x over x will cancel out, x over x will cancel out, and x over x will cancel out. So 3 of these guys will completely cancel, leaving you with just 2 in the top, which means you have x squared left over in the top. Okay, let's look at another example. Maybe you have y to the sixth over y to the fifth. Then you can see that you have y times y times y times y times y 6 times in the top, and y times y times y times y times y 5 times in the bottom. And again, you can count off how many are going to cancel. So you can partner up these guys, these guys, these guys, these guys, these guys, and you can partner up 5 in the top and 5 in the bottom to cancel out, leaving you with just one solitary y in the top, aka y or y to the first power as your final answer. So the way I like to think about this is as if it's some kind of battle between the numerator and the denominator. You've got a certain number of soldiers in the top and a certain number of soldiers in the bottom, and as long as they're the same type, y's with y's or x's with x's, they can fight against each other and cancel each other out. So whichever side has more troops is going to win. You can do it even with different types of variables. So say you have a to the fifth and b to the eighth over a squared b cubed. Okay, I like to think of each letter as representing some different type of troop. So I've got my A for maybe admirals. I've got 5 admirals here and 2 admirals here. So the top has more admirals, they're going to win, and they're going to win by 3. So I've got a to the third power in the top. And in the second part, I've got b to the 8th. So maybe I've got bazooka men, 8 of them in the top and only 3 of them in the bottom. So the top will win. So there will be bazooka men, 3 will kill each other, leaving behind 5 bazooka men in the top. And I know it seems kind of silly. You could think of them as zombies fighting against each other, or soldiers, or anything like that. But the thing to remember is, whether it's the numerator or the denominator, whichever side has more is going to win. So if the top has b to the 8th and the bottom has b to the 3rd, there's more in the top, they'll be left over in the top. So let's maybe look at an example. Well, let's try to make up a rule. Using these 3 examples, let's make up a rule for the pattern that we have found. So what pattern have you seen? What you should notice so far is that in every case, you take the top number and you subtract the bottom number to get your final answer, because subtracting is telling you how many of them are going to cancel out. So if you have x to the a divided by x to the b, your answer is going to be x to the a minus b. And this rule works for dividing exponents. It doesn't matter, a and b could be any numbers, and when you divide them, you keep the base the same, the base stays as x, and you subtract the exponents. Okay, let's look at a couple more examples. So exponential expressions, we can do something like, let's try p to the 4th times q to the 8th over p q to the 3rd. Okay, if we just look at our p's, we have 4 in the top and 1 in the bottom. We subtract 4 minus 1, and we get p cubed. Okay, then we have q to the 8th and q to the 3rd. We subtract 8 minus 3, leaving us with q to the 5th. So all you do is subtract. And again, if you forget how to do this, all you have to do is, you can always write them out longhand. Write down p times p times p times p 4 times, and then q 8 times, and cancel them out piece by piece, and you'll always get the right answer. Okay, let's take one final example here. What if you have x to the 3rd, y to the 5th, over x to the 7th, y squared, something like this. So here, if we look at the x's and we subtract, we get 3 minus 7, which is x to the negative 4th, and then y to the 5th divided by y squared. Then we subtract 5 minus 2, and we get y to the 3rd. So we've come across something new here. What is this negative exponent? X to the negative 4th, what does that actually mean? So in the very next video, we're going to learn all about negative exponents. And so I encourage you to take a look there, and we'll talk about what it means and how there's different ways to write it, etc., etc.